Buyer in Singapore are asking MegaCorp's app the same supplier catalog questions thousands of times an hour. Every time, the answer travels all the way back to the database, gets recomputed from scratch, and comes back slow. The data barely changes. So why is the database doing the same expensive work again and again? This is Stack Lessons, and this is Cloud Architect Path. By the end of this video, you'll know exactly which Amazon Web Services caching layer fixes which bottleneck, and how to make the right call the moment you read the scenario. We'll map ElastiCache, DAX, and CloudFront to the problems they each solve, and settle the Redis versus Memcached decision that sits inside ElastiCache. In episode 26, MegaCorp broke its Oracle monolith into 6 purpose-built engines. The high-traffic product catalog went to DynamoDB, the core ERP landed on Aurora, and historical analytics moved to Redshift. We also met DAX briefly as DynamoDB's in-memory accelerator that pulls read latency down into microseconds. Today we go one layer higher. Instead of choosing the right database, we're choosing the caches that sit in front of those databases. 5 terms will anchor everything that follows. ElastiCache is a managed in-memory caching service. Frequently read data lives in RAM and comes back in under a millisecond. DAX is DynamoDB Accelerator, an in-memory cache built specifically for DynamoDB that drops read latency into microseconds. CloudFront is a global content delivery network that caches content at edge locations close to your users. Lazy loading, also called cache-aside, means the app checks the cache first and only touches the database on a miss. And session state externalization means keeping session data in a shared store instead of on individual servers. Let's make MegaCorp's problem concrete. Thousands of buyers hit the same supplier catalog entries every hour, and every one of those requests round trips to RDS. That's a structured query language query taking 50 to 100 milliseconds, often joining several tables together. Now stack up hundreds of those at once. The database's CPU saturates, requests queue behind each other, and tail latency blows past 900 milliseconds. Here's the key insight though. The data is repetitive and barely changes between requests. That's the textbook signal for a cache. Before we reach for a service, here's the idea that ties this whole topic together. Amazon Web Services offers caching at several different layers, and each one targets a different bottleneck. There is no single cache that fixes everything. The skill being tested is reading the scenario, finding the actual source of the slowness, and matching the right layer to it. Pick the wrong layer for the wrong bottleneck, and you've solved nothing. So here's the map we'll keep coming back to. Repetitive relational reads from RDS or Aurora, that's ElastiCache. DynamoDB reads that need microsecond latency, that's DAX, the specialist. Global static web content for users around the world, that's CloudFront at the edge. And shared session state, so your app tier can scale freely, that's ElastiCache or DynamoDB. 4 bottlenecks, 1 decision each. The trick is always the same. Read the scenario and identify where the slowness actually comes from. Start with MegaCorp's actual bottleneck, repetitive reads hammering RDS. ElastiCache is the fix. It's a fully managed in-memory store, and it runs one of 3 engines: Valkey, Redis, OS, or Memcached. We'll get to that choice shortly. The core idea is simple. Frequently read data lives in memory, so it comes back in sub-millisecond time instead of round-tripping to disk. You put ElastiCache in front of RDS or Aurora, and it absorbs the repetitive reads before they ever reach the database. Amazon Web Services documents up to 80 times faster read performance compared to disk-based databases. Picture a busy restaurant. RDS is the main kitchen, and every trip back to it costs 50 to 100 milliseconds. ElastiCache is a small hot plate right at the server station, keeping the most frequently ordered dishes warm and ready. The first order of each dish still goes back to the kitchen, but every repeat order after that gets served from the hot plate in a fraction of a second. MegaCorp's supplier catalog is exactly that frequently ordered dish. The pattern that makes this work is called lazy loading or cache aside. Walk through it. On the first request, the app checks the cache, finds nothing. That's a miss. So it fetches from RDS and then writes that result back into the cache with a time to live attached. Now, every repeat request for the same catalog entry finds the data already warm. That's a hit, served in under a millisecond, and RDS never gets touched. You pay the price of the expensive query exactly once, then retrieve the answer cheaply as many times as you need. Look at what this does to the numbers. A cache miss still costs you that 90 millisecond database query, but a cache hit comes back in about a single millisecond, roughly 2 orders of magnitude faster. Because the vast majority of requests are hits, the database sheds a significant share of its load. MegaCorp's tail latency collapses towards single-digit milliseconds for anything served from cache. The Amazon Web Services documentation on ElastiCache use cases puts the logic plainly. By caching query results, you pay the price of the query only once, and then you retrieve the data many times without ever having to rerun it. That's the entire economic argument. One expensive database query gets amortized across thousands of cheap, fast cache reads, which is exactly the shape of MegaCorp's repetitive catalog traffic. Now, inside ElastiCache, you pick an engine, and this is a decision the exam loves. Redis and its open source fork Valkey gives you the rich feature set, persistence to disk, replication with multi-AZ automatic failover, and advanced data structures like sorted sets for leaderboards and geospatial indexes. It also supports backup and restore, letting you snapshot and recover the cache. And it's the default for most new workloads. Memcached is the opposite philosophy. It's a simple string key value store with no persistence, no replication, and no failover. It is multi-threaded, so it scales across many CPU cores, but its nodes are disposable. Losing them is fine. Reach for Memcached only when that raw simplicity is the entire requirement. Here's a picture that locks the difference in. Memcached is a whiteboard in the office break room. Fast to write on, easy to erase, and if someone knocks it over tonight, whatever it said is gone by morning. Redis is that same whiteboard, but with a built-in camera that photographs every change and automatically copies it to a backup board in another room. Knock it over, and Redis can restore exactly what it said. The camera and the backup board are persistence, replication, and multi-AZ failover. Amazon Web Services actually spells out when Memcached is the right call. Choose it when you need the simplest possible model, when you want large nodes with multiple cores or threads, when you need to scale nodes out and in as demand changes, and when you're simply caching objects. Notice what's absent from that list? Nothing about high availability, nothing about persistence, nothing about advanced data types. When any of those show up in a scenario, the answer swings back to Redis or Valkey. A practical shortcut, if you're not sure which to choose Redis, because it can do everything Memcached does and more. One quick note on naming, because it changed recently. In March 2024, Redis announced that version 7.4 would move to a dual license that is no longer open source. In response, the Linux Foundation launched Valkey in early April 2024, a BSD license fork of Redis 7.2. Amazon Web Services now recommends Valkey as the default open source engine on ElastiCache. For everything on this exam, treat Valkey and Redis as the same feature story: high availability, persistence, and rich data structures. Only the name and the license change, not the decision rule. Let's lock in ElastiCache before we move on. It offloads repetitive relational reads from RDS and Aurora. Lazy loading is the pattern, A miss fetches from the database and populates the cache, and every hit after that serves in under a millisecond. Choose Redis or Valk when you need high availability, persistence, or advanced structures, and that's your safe default. Reserve Memcached for the narrow case of simple, multi-threaded disposable object caching. Now, that's the answer for relational databases. DynamoDB is a completely different story. When the database is DynamoDB, the caching answer is DAX. It's a fully managed DynamoDB-compatible in-memory cache, and the magic is that it transparently intercepts your DynamoDB API calls. You point your existing SDK at the DAX endpoint, and it just works, little or no code change. Under the hood, it keeps two caches. An item cache handles direct lookups by primary key, and a query cache stores the result sets from queries and scans. The thing to burn in here? DAX is a different service from ElastiCache, purpose-built for one database and one database only. Here's the performance claim in Amazon Web Services' own words. As an in-memory cache, DAX reduces the response times of eventually consistent read workloads by an order of magnitude, from single-digit milliseconds down to microseconds. And a multi-AZ DAX cluster can serve millions of requests per second. That word, microseconds, is your signal. When a scenario says DynamoDB and microseconds in the same breath, DAX is the target answer. Think of it as a specialist versus a generalist. DAX is the specialist. It speaks DynamoDB's API fluently, manages cache population and invalidation for you automatically, and delivers microsecond reads at millions of requests per second, all with minimal or zero code changes. ElastiCache is the highly capable generalist. It does not speak DynamoDB natively, so you'd have to handwrite all the cache lookup, population, and invalidation logic yourself. ElastiCache is fantastic in front of RDS and Aurora, but it is not the DynamoDB answer. Reaching for it there means more work and more risk of serving stale or mismatched data. DAX is purpose-built for DynamoDB's API, so it handles cache population and invalidation automatically in microseconds. ElastiCache, by contrast, forces you to handwrite all that logic yourself and doesn't speak DynamoDB natively. It's the wrong tool for that job. This distinction is heavily tested, so it's worth locking in. There's one important catch. DAX only accelerates eventually consistent reads. If your application demands strongly consistent reads, those bypass DAX entirely and go straight to DynamoDB, so they get no speed boost. On writes, DAX is a write-through cache. The write is applied to both DAX and DynamoDB, keeping the DynamoDB table as the authoritative system of record. That means there's no risk of serving stale data from the cache after a write. The bottom line, DAX shines for read-heavy workloads. If your app is write-intensive, the cache overhead buys you very little. Our third bottleneck is geography, and that's where CloudFront comes in. CloudFront is a global content delivery network with over 750 edge locations across more than 440 cities, caching content close to your users. On a cache hit, the content is served instantly from the nearby edge. On a miss, CloudFront fetches from your origin, caches it, and every later request for that same content is fast. The origin can be an S3 bucket, an application load balancer, or any custom HTTP server. For MegaCorp, the supplier product datasheets and thumbnail images are perfect edge cacheable assets. Here's the mental picture. Imagine MegaCorp made every buyer fly to Singapore just to read the supplier catalog. Absurd, right? CloudFront does the opposite. It prints a copy of each catalog page and ships it to a local copy room in over 440 cities around the world. A buyer in Frankfurt walks to the Frankfurt copy room instead of booking a flight. That's the whole idea. You can't make Singapore closer, so you move the content nearer to the user. A European buyer fetching a document straight from the Singapore origin, eats roughly 200 to 300 milliseconds of network round trip before any real work even begins. That same document served from a Frankfurt Edge cache comes back in 5 to 15 milliseconds. Together, those wins mean CloudFront absorbs the bulk of those requests, often 80 to 99% of static asset traffic, so the origin server barely feels the load. Amazon Web Services frames that dual benefit directly. With CloudFront caching, more objects are served from edge locations, which are closer to your users. That reduces the load on your origin server, and it reduces latency at the same time. One control, two problems solved. The origin gets relief while your global users get speed. There's one confusion worth heading off. CloudFront and Global Accelerator both use the Amazon Web Services Edge network, but they do different jobs. CloudFront caches content at edge locations. It's the answer for static assets, document previews, and anything described as a CDN. Watch for the words edge, global users, and reduce origin load. Global Accelerator routes traffic to the nearest healthy region, but it does not cache anything. Its queues are anycast IP addresses and routing to the nearest endpoint. So the deciding question is simple. If the scenario is about serving or caching content, it's CloudFront. If it's purely about routing with no caching, it isn't. Our last pattern is a bit different. It's not about read latency, it's about scaling. If you store user sessions in each server's local memory, your load balancer has to use sticky sessions to keep sending each user back to the same instance. And that quietly breaks everything. Sticky sessions pin a user to one machine, so autoscaling can't freely terminate that instance without disrupting people. Worse, if the instance dies, the session dies with it, and the user is thrown back to a login screen. The fix is to externalize session state into a shared store. Think of a session as a coat. Without a shared store, each waiter, each app server keeps your coat in their own personal locker. If that waiter goes home early, your coat is gone. Externalizing session state is a central coat check room. Every coat goes into one shared place, so any waiter can retrieve any customer's coat, and the room stays open even when individual waiters leave for the night. That's why a shared store lets any server handle any request. This isn't just a nice idea, it's a formal Amazon Web Services recommendation. The well-architected framework says services should either not require state or should offload it, so that between requests, there's no dependence on data stored locally on any one server. That lets servers be replaced at will without hurting availability. And it names the destinations explicitly. Amazon ElastiCache or Amazon DynamoDB are good places to offload that state. You've got two solid choices for that shared store. ElastiCache with Redis gives you a fast in-memory session store with high availability through multi-AZ. DynamoDB is the fully serverless, durable alternative when you'd rather not manage a cache cluster at all. Either way, the payoff is the same. Any app server can serve any request, so you drop sticky sessions entirely, and autoscaling is free to add and remove instances whenever it wants. The web tier becomes truly stateless and horizontally scalable. Let's assemble MegaCorp's complete design. At the edge, CloudFront serves supplier PDF previews and product images to buyers everywhere in the world in milliseconds. Behind it sits a stateless app tier because session state lives externally. That app tier reads through ElastiCache, which holds both the catalog reads and the shared sessions. And only on a cache miss does traffic reach RDS or Aurora underneath, which is why the database now carries 60 to 90% less load. Put together, MegaCorp's tail latency falls from over 900 milliseconds to single-digit milliseconds for cached requests. 4 decisions that quietly break caching in production. First, always set a time to store it on cached data. If MegaCorp updates a product price in RDS, but the cache holds the old value for hours, buyers see the wrong price. Second, Memcached has no replication, no failover, and no persistence. So it's the wrong choice when high availability is the requirement. Third, sticky sessions pin users to specific servers, which blocks horizontal scaling. Externalized session state is what actually lets you add capacity freely. And fourth, when the source of truth is DynamoDB, reach for DAX, not ElastiCache. DAX is the native answer for that pairing. Here's the whole topic on one page. Repetitive reads from RDS or Aurora go to ElastiCache, with Redis or Valk as your default engine. Inside ElastiCache, high availability, persistence, or advanced structures means Redis, while simple and disposable means Memcached. DynamoDB plus microsecond reads means DAX, never ElastiCache. Global static content and reducing origin load means CloudFront, not global accelerator. And a stateless, horizontally scalable app tier means session state in ElastiCache or DynamoDB. Now let's see how well you absorbed all of this with a quick 5-question quiz. Question 1. MegaCorp Singapore app has tail latency above 900 milliseconds because thousands of identical supplier catalog queries round-trip to an RDS postgradable database and saturate its CPU. Which change most directly reduces both the database load and the latency? Option A, add a DAX cluster in front of the RDS database. Option B, place ElastiCache in front of RDS using a lazy loading pattern. Option C, enable an RDS read replica and route all catalog queries to it. Or option D, front the application with CloudFront to cache the SQL responses. Run the layer to bottleneck map before you answer. This one is B. The ElastiCache with lazy loading holds the repetitive query results in memory, so repeat reads come back in under a millisecond and never touch RDS. DAX is for DynamoDB, not relational databases, and CloudFront caches web content, not structured query language result sets. A read replica adds read capacity but still runs the same expensive query every time. Question 2. An application stores its product catalog in DynamoDB, and during a flash sale, one popular item's partition starts throttling under read load. The team needs microsecond read latency with minimal code changes. What should they use? Option A, ElastiCache for Redis with a manually managed cache-aside layer. Option B, ElastiCache for Memcached as a multi-threaded object cache. Option C, DynamoDB Accelerator, DAX. Or option D, a CloudFront distribution with DynamoDB as the origin. Lock in your answer before I give it away. It has to be C, and here's why. DAX is the purpose-built, API-compatible cache for DynamoDB, microsecond reads, millions of requests per second, and almost no code change because your existing SDK just points at the DAX endpoint. Both ElastiCache options would force you to hand-write cache logic, and CloudFront caches web content, not DynamoDB table reads. DynamoDB plus microseconds always points to DAX. Question 3. A team needs an ElastiCache deployment that survives an availability zone failure without losing cached data, supports automatic failover, and provides a sorted set structure for a real-time leaderboard. Which engine meets all three requirements? Option A, Memcached because it is multi-threaded and scales across cores. Option B, Redis or Valk with a replication group and multi-AZ failover. Option C, Memcached with an added read replica for the leaderboard. Or option D, either engine, since both support persistence and sorted sets. Think about which engine actually has these features. The right call here is B. Only Redis or Valk gives you all three, persistence, replication with multi-ISI automatic failover, and advanced structures like sorted sets for that leaderboard. Memcached has none of them. No replication, no failover, no sorted sets, and it doesn't offer read replicas either. When high availability or rich data types appear in the scenario, the answer is Redis. Question 4. MegaCorp's buyers across Europe and North America frequently download supplier PDF datasheets stored in an S3 bucket in Singapore, and the transfers feel slow. The goal is to cut latency for these global users and reduce load on the S3 origin. What's the best solution? Option A, Amazon Web Services Global Accelerator, pointing at the S3 bucket. Option B, an ElastiCache cluster, caching the PDF files in memory. Option C, Route 53 latency-based routing to the nearest region. Or option D, a CloudFront distribution with the S3 bucket as origin. Got your pick? Let's see. If you said D, well done. CloudFront caches those PDFs at edge locations near your users, serving them in a handful of milliseconds and absorbing most of the requests so the Singapore origin sees far less traffic. Global Accelerator and Route 53 both route traffic, but cache nothing. And ElastiCache is a database cache, not a content delivery network. Edge, global users, reduce origin load. That's CloudFront. Question 5. A web app behind an application load balancer stores user sessions in each instance's local memory, which forces sticky sessions. When auto-scaling terminates an instance, those users get logged out. What's the recommended fix for a stateless, horizontally scalable tier? Option A, externalize session state to ElastiCache or DynamoDB. Option B, increase the load balancer sticky session duration to keep users pinned. Option C, store sessions on an EBS volume attached to each instance. Or option D, disable auto-scaling so no instances are terminated. Pause here if you want more time. The answer is A. The well-architected framework says to offload session state into a shared store like ElastiCache or DynamoDB, so any instance can serve any requests, and auto-scaling is free to add or remove machines. Longer sticky sessions and instance local EBS volumes only deepen the coupling to individual servers, and disabling auto-scaling throws away the whole point of a scalable tier. Externalize the state, and the web tier becomes truly stateless. And that's the whole story on caching layers: ElastiCache, DAX, and CloudFront. Subscribe so the rest of the Cloud Architect path reaches you without effort, and so the algorithm spreads it to new learners. I read every comment, so share what helped and what was fuzzy. Suggestions for the next certification are always open. And if the pacing or style could be better, say the word. See you soon.